Okay, I think we are live, so let me just reduce this. Okay. Hi everyone, and I'll wait for some time while others join in. Meanwhile, we can actually have a discussion around how did the contest go, and how many of you were able to solve both the problems, or is there a problem you were not able to solve, or maybe what are the approaches that you've tried to solve that. Let's have a discussion around that while others join in. So we'll start from around, let's say, 2 minutes from now, 2 to 3 minutes from now. So yeah, let me know about like how did the contest go and the details, right? So let's have some discussion around that. Is my feed live? That's I think it's so. Yeah, let me know. No one is answering anything. I'll wait for your answers. Like, tell me, how did the contest go overall? Like, did you like the problems? Did you not like the problems? What do you think about the difficulty? Like, was it hard? Was it easy? Was it medium? Like, it something like around that. And how many were you able to solve? Which problem were you not able to solve? What are the approaches that you have tried? You can actually share those details. Let's have a discussion. Is second question related to DP? We'll see. Second question, I don't remember exactly, but yeah, like we'll see if it is related to DP. Um, Once we go to that, we'll see, right? So, but I don't think there was any DP problem, right? Let me just verify quickly once. Given length str of digits, the length of the longest substring is the length of the substring is 2k, the sum of the left k. I don't think it's a DP, right? It's a brute force problem, I feel. Sliding window, yes. Maybe sliding window, maybe brute force, like everything you can do, right? I wouldn't say it's an exact sliding window, but again, like you can definitely solve using a sliding window algorithm. Uh, yeah, definitely. Tried the first one, got stuck in test case, second didn't attempt. Okay, Yash wasn't able to solve. That's totally fine. Like, so let's start with the discussion, right? Let's start with the discussion. I think many of you have joined in, and I'm stuck with logic. No worries, no worries. We'll understand, right? Actually, first one is a bit tricky, so I do agree that it was okay to be stuck, right? In fact, I might have been stuck as well. It was a bit tricky here, but again, like let's see. So you have to solve the problem. The problem name is cutting rectangles. Now you're given a rectangle of dimensions L cross B. So the dimensions of the rectangle is L cross B. L is the length, B is the breadth, and find the minimum number n of minimum number n of identical squares of maximum side that can be cut out of the rectangle so that no residue remains in the rectangle, right? So you have to also find the dimension of that square, that is k, right? So what you have to do is, you are given a rectangle, right? You have to cut largest possible you have to cut largest possible squares out of it, such that the squares, like you can convert the entire rectangle into squares. You can cut out squares from the entire rectangle, and no space of the rectangle is remaining. Like there is no part of the rectangle that actually remains, and you have to return how many squares are you, and you have to cut out maximum length squares, right? So you have to cut out you have to find n, what is the maximum length, also number the dimension, and also how many squares are you able to cut, right? So for example, when L is 2, B is 4, right, you can cut 2 cross 2 squares, right? Tell us the concepts of number theory for interviews. I don't think it's a number theory problem exactly. Like it's a simple like observation and a bit of mathematics problem, but again, like it's not a number theory exactly, right? And interview also, you will not be asked any hardcore. Modular arithmetic is a part of number theory, I agree, and that might be asked, but this is again not a part of modular arithmetic as well. So yeah, but this is a mathematical, definitely a mathematical question. So L is 2, B is 4, and you can cut out two squares of size 2 plus 2, right? So that actually makes sense, right? So L is 2, let's say L is 2, B is 4, so B is 4, L is 2, right? L is 2, so this is 2, this is 4. So you can cut out 2 cross 2 squares like this, one square 2 cross 2 and second square 2 cross 2. So you are cutting out two squares each of dimension 2 cross 2, and you cannot cut anything more than that, right? You cannot cut anything more than that. So that's the first one. Second one is the dimensions are 6 and 3. L is 6, B is 3, and you can cut out 6 3, so 3 is the side length, and you can cut out two squares again, 3 cross 3, two squares, right? So this is the question that is given to you. Now how do you solve this, right? This is the question. I think the question is clear with everyone, so you must have spent a lot of time around this, but let's actually understand the solution. Okay, so you are given a rectangle where the length is L and the breadth is B, right? You have to cut out squares, right? Now how will the squares fit in? First of all, let's think about this. How will the squares fit in? The squares, if you think about this, the squares will always come like this, like they will be coming like this, something like this. There will be multiple squares, let's say, and they will be something like this only, right? So this means that the squares should actually cover up this entire length, right? The square sides should actually make up this entire length. The square sides should also make up this entire breadth. What do I mean by make up? Like, you cannot have a partial, like you cannot have a point of the square that's coming to this part, right? You will have an entire side both on the length and both on the breadth, and you want to utilize this entire rectangle. So what does this mean? Utilize this entire rectangle. It means that the length should be covered. The length should be entirely covered by side of a square, right? So the length should be equals to some, let's say there are some x squares along the length. So x into the size of the square, let's say k. So L is equals to x into k. Similarly, the breadth of the square, the breadth of the rectangle should also be covered by the squares as well. So B is also equals to, let's say there are y squares along this line. So y into k, right? K is the side of a square, where k is the side of a square, like all the squares are of dimension k cross k, sorry. Yep. So that's the only way possible, right? That's how it will occupy the entire square. There is no other way. Like you wouldn't cut out a square like from the center and just make a point touch to the length. So you will always cut out the squares like this, right? The best possible answer will always be along these lines, right? So our length will be a multiple of k, our breadth will be a multiple of k, right? This tells us that what is the maximum value of k. Do we see something similar here? What is the maximum value of k? We have to maximize k. What is the maximum value of k such that the length is divisible by k and the breadth is divisible by k? Do we know such a value which is the maximum value of k, that such that both the length and the breadth are divisible by k? Do we know such a value? Can anyone tell? Do we know such a value such that both the length and the breadth are divisible by k? Because our length should be a multiple of k, because you see that the sides of the square are occupying the length. So it's and the entire rectangle should be cut out. So length is equals to x into k, breadth is equals to y into k. So is there a value of k? Is there a value of k, or what is the maximum value of k such that both the length and breadth are divisible by k? Is there a value? Yes, the GCD. Yes, GCD, exactly. GCD will divide. So given two integers, just think about it like this, that hey, we are given two integers p and q. We are given two integers p and q. What is the largest number g that divides both p and q? What is the largest number p that divides both p and q? That is the definition of GCD, right? G equals to the GCD of p comma q. G equals to the GCD of p comma q. So what you have to do is, you got the side length, k is equals to the GCD of L comma B, GCD of L comma B, and once that you've got this number of squares, n will be equals to what? whatever is so it will be basically equals to length by k into breadth by k, or you can do length into breadth by k into k, but just to prevent overflow you can do it like this as well. Basically the number of squares will be x into y, right, where l equals to x into k and y b equals to y into k, right? So the number of squares will be x into y. So simple, right? So you have to find the GCD of P and Q or L and B. That will be the side of the square, and how many squares will be there? It will be L into K by B into K. Good evening. So B into K. So this is how we can do it. Pretty simple, right? Just the observation was that you have to visualize that, hey, the entire length will be occupied by a side of the square, right? The entire breadth will be occupied by a side of the square. That's the entire observation. So actually we have a GCD method, so I think I'll be just using that. So long g equals to, or let's call it k, the side of a square equals to, or we can also write the code for GCD. It's not very difficult, right? We can do both ways. So L comma B, GCD will be L comma B, the side of a square, and n will be, so long number of squares will be L by k into B by k. So what is the order in which we return? We return n and k. So vector return, we return n and k. I think this order we return. So let's compile and run. Any doubts with this? Any doubts? 2 and I think that's the expected as well. That should be the expected. So let's submit and see if this is working. Okay, it's working, right? So that's the observation, like the entire length will be occupying, the entire breadth will be occupying. So what is the largest number? Because the entire length occupying, it means that it should be divisible by k. The entire breadth is occupying, it means that it should be divisible by k. So what is the largest number that divides both of these numbers? So it's eventually just GCD, nothing else, right? So this was just observation and 3 lines of code. So I understand if you are feeling terrible about this, but yeah, like that's not an issue. Like it was pretty observation based. So it's okay if you were not able to solve. Just be careful about this, right? Because GCD is a very like is a very popular question, like popular domain in which questions are asked. Anyways, let's move to the second one. For the second one, actually, I don't think there is a lot of explanation required. It's basically whatever is given to you in the question, you just have to replicate it in the code, right? And if you see the constraints actually also pass, you just have n square complexity, auxiliary space is also n square, although we don't need auxiliary space, I believe. But anyways, we actually can do it without auxiliary space as well. So you are given, I think I've not read it wrong. So for a given string str of digits, find the length of the longest substring of str such that the length of the substring is 2k digits and the sum of the left k digits is equals to the sum of the right k digits. So you are given a string of 2k. Yes, I understand, John. I have also been like GCD has been a nightmare to me as well, so I can totally relate, right? So yep, so you're given a string with some digits. Now you have to find the longest substring of 2k digits such that the leftmost k digits sum and the rightmost k digits sum, or the right k digits sum, that they are same, right? So basically here, if you see, you can have a length of 6. So the first 3 and the last 3 will have the same sum. So you have to find the longest substring like this, or 1 2 3 4 1 2 3. I think the size will be 4. So why is the size 4? Let's understand that. 4 will be 1 2 3 4 1, maybe 4 1 5. Yes, 2 3 4 1. So 2 3 plus 4 1, both of them are same. So there is nothing actually rocket science. You have to just do whatever is told, and you have been given very liberal time complexity and space complexity, so you can just do a brute force solution, right? The idea being that, hey, why not? So see, you have to find a length 2n, right? So let's say we just have to fix a starting point. Let's have some 1 2 3. 1 2 3 4 1 2 3, I believe that was the question. So we will start with this possible set of middle starting points, right? So for middle, these two initially can be the candidate solution, but if you see these two, we cannot expand because we cannot expand on the left hand side. So we'll go, so the sum is not equal, so we'll go ahead, right? We'll go ahead. So the next possible solution will be these two. Now here we can actually expand. We can expand by one place. We'll come here, we'll come here, we'll see if the sum on the left and right is same. Is the sum same? 2 plus 1 3, 4 plus 3, it is not same, so it is not possible. So we are done, right? So we'll go to the next set of pairs. So 3 4 3 4 will come to 2, will come to 1. Like this is obviously 3 4 is a valid pair, but the sum is not valid. So 2 3 4 1, we see that the sum of left and right is same, so we mark it as length is equals to 4, we mark it as 4. Then we will update, like we can go more, so we'll go right one step, left one step, and we'll see if the sum is same. So 1 2 3 4 1 2, they are not same, so we'll skip to the next pairs, right? To the next pair 4 1. So like this we can just do, right? And what is the complexity? The first pointer is running or on this length, like these two pointers are running, but again, like it's a both are running at the same time, so it's order of n for these two. Inside that, what we are doing, we are exploding on both the sides together, so we are at max we are going n by 2 length, so it's order of n, so it's n into n, which is order of n square, right? So it's just order of n square solution. Pretty simple, right? So we can look into the code directly. I'm not elaborating, like let me know if I need to elaborate on this, but I feel that it's pretty brute force. So I'm just going with the code. So let's call ptr1 equals to 0, ptr2 equals to 1. So while, and let's mark n here as well, n equals to str dot size or length, whatever. So while ptr2 less than n, right? First of all, we'll check what is the maximum answer we can get. So we'll mark the answer here. Definitely answer equals to 0, and we'll return our answer. This will be the answer that we return. Now we'll see, now we'll maintain a running sum, right? So in left sum, L sum, let's call it L sum, left sum is equals to, only one element is there, that is the left pointer element. So str of ptr1 minus a, or we can make a method here, right? We can make a method is int get digit value, and we can pass in a character here, char x, and return, it will be return of integer x minus a, right? So that will be there. So we can just do like this, that get digit value, get digit value, sorry, get digit value for what? For str ptr1, and r sum equals to get digit value str ptr2. So if L sum equals to R sum, in that case answer equals to max answer and or 2. Otherwise we'll run the second loop. So second loop will be int left is equals to ptr1 minus 1, and right equals to ptr2 plus 1, while left greater than equal to 0 and right less than n, and finally we'll do left plus plus and right minus minus, sorry, left minus minus, right plus plus. We'll move to the left and right, right? So we'll add the current value to the sum. So L sum plus equals to get digit value str of left, R sum plus equals to get digit value str of right, and if again same condition, if L sum equals to R sum, then answer equals to what? Answer equals to max of answer or right minus left plus 1. Right minus left plus 1. Right. Right minus left plus 1. Whatever is the length of that substring. So that's there. And finally, we have to do PTR1 plus plus, PTR2 plus plus. So PTR1 plus plus, PTR2 plus plus. Right. So that should be it. Let's see if this is working. There's nothing complicated, like we are just fixing the centers and we are moving both ends. So str dot size, hey, n shadows are parent. Okay, n is given to us, right? So we don't need this n. Okay, we are getting 4. Let's submit and see. I hope that this is not wrong. Let's see. But okay, working, right? So yeah, so this is also done. Let me know if you have any doubt with this code as well. I think it's pretty simple. Like what I'm doing is I'm just going through all possible centers and then moving both left and right and generating like the sum, right? So it's the time complexity is order of n squared. The space complexity is basically it's just order of 1, right? So it's order of 1 space complexity, which is much better than the expected one as well. So anyone has any doubt with this? It's pretty simple, I believe. Let me know if you have any doubt. Any doubts on this? Any doubts on any of the in any both in the previous question, this question? Any doubts that you have that I can help you with? We are done with both the questions. So yeah, like the lecture is over. But yeah, if you have doubts, I'd like to take them as well. John, I understand. The second one I didn't explain properly because it's just brute force. There is not much to explain here. I can definitely, like, if you didn't understand something, I can definitely explain. But again, like, this is nothing but brute force. I'm just going through all the places and I'm going left and right and I'm doing whatever the question asks me to do, right? So there's nothing extra that I've done. That's why my explanation has been I made it shorter. But again, like, if you need me to explain, I'll definitely explain. I'll explain properly with test cases and stuff. But yeah, like, only if you need it, right? Explain the logic again. See, if you want the explanation, definitely I'll explain, right? There's no point. Like, I don't have any problem with this. So let's understand this. Okay. So what are we given? What are we given? So just let me clear. 1, 2, 3, 4. 1, 2, 3, 4, 3, 2, 1, I believe was the test case. Okay. You have to find a substring of length 2k such that the first k digits sum of first k digits is equals to the sum of the next k digits, right? So if the first k digit sum is equals to the next k digit sum, and you have to find the substring maximum length substring of length 2k, where k is like 2k is a multiple of 2, right? Because there will be left k digits and there will be right k digits, right? So that's why it will be of size 2k. So you have to find such maximum 2k. The idea being that whatever the question asks, right, we will try to generate all 2k, like all the substrings of length 2k, and we'll find if their sum of the left hand side and the right hand side is same. So the idea being, first of all, like, we'll focus on the centers. Like, let's say a string is of length 4, right? So let's say d1, d2, or 6, let's say 6, d4, d5, d6. What is the center for this? These two are the centers, right? This is the part on the left hand side, this is the part on the left hand side, this is a part on the right hand side. So we will fix these two things, d3 and d4, and we will try to extrapolate on how many, what is the maximum length string that we can get centered around d1, d3 and d4. So we will loop over all the centers, right? So the first center, what is the first center that we have? So for that reason, we have 2 pointers. The first pointer initially center will be the first element, for the left hand part. The right hand part will be the second element. This will be the first center and the second the first centers. Now here the sum is 1, the right sum is 2, right? Left sum is 1, right sum is 2. So we cannot move to the left, we cannot move to the left, right? We cannot move anymore to the left. So, and also we cannot move anymore to the right, because we cannot move to the left. The sum has to be 2k, and this will basically mark the center of the left part or end of the left part. This should mark the beginning of the right part. So as we cannot move to the left, we will also not move to the right, because these are the centers. So this is not a valid one. The answer still remains 0, right? Answer is equals to 0. Let's go ahead. So we'll go to the next possible center is 2 3. Next possible center is 2 3. Okay, so we'll maintain the left sum and the right sum. We'll maintain the left sum. So initially we'll maintain the left sum. Left sum is 2, right? Left sum only contains 2, and the right sum is 3 because it contains 3. Now can we expand on this center? Yes, we can, because there is an element on the left, there is an element on the right. So we can expand on this center. So we come here and we come here. We add 1 to the left sum. So the left sum becomes 3. We add 4 to the right sum. So the right sum becomes 4 plus 3, that is 7. Basically the substring that we have generated here is 1 2 3 4. The left part has 1 2, right part has 3 4. So is the sum same? The sum is not same. Okay, can we extrapolate more? Can we get more substrings? No, right? We cannot move to the left anymore. So we end here and the answer still remains 0. Answer still remains 0. Let's go to the next center. So the next center will be what? Next center, Neetu, the next center will be what? The previous center was 2 3. The next center will be? Anyone? What will be the next center? What will be the next center? 2 3 was the previous center. What will be the next center? 4 3. Yes, exactly. So 3 4 will be the next center. We'll start from here again. So the left has a sum of what? The left has a sum of 3, right has a sum of 4 initially. 3 4. Now we are going to the left. We can extend. So we'll go to 2, and we'll go to here. We'll go to 3. So the sum on the left is plus 2. 3 plus 2 will become 5. Sum on the right plus 3. 4 plus 3 will become 7. So is there sum equal? Is there sum equal? No, sum is not equal. Can we extend more? Yes, we can extend more. So we'll extend more. We'll go to 1. It will become 6. The left sum will become 6, and this one will go to 2. So 6 2. So this will become 6, and this will plus 2 7 8 9. This will become 9. Are they same? No, we cannot expand anymore, right? We cannot expand anymore. So we'll stop here. Okay, we got that. This is also done. This center is done. Next we'll move to the next center, that is 4 3. This one. Initially we have 4 and 3. 4, and here we have 3. We'll move to the left. We can expand, right? 3 plus 3 to 4 will become 7. 4 will become 7. The right one will also move it one place to the right. So it goes to 2, and it will become 3 plus 2 5. 5. Are they same? Is the sum same? No, right? So we can expand again. We can still expand on the left. So it will come to 2, and it will come to 1. So it will go to 2. This 2. This will go to 1. What is the sum? Plus 2, 7 plus 2 is 9. And here 5 plus 1 is 6. 1 second. 6, and have I taken a wrong example? 1 2 3 4 1 2 3. 1 2 3 4 3 2 1 I've taken. Okay, that's why we are not getting anything. I've actually taken a wrong example, but again, like let's just do that. 1 2 3, that one. 1 2 3 4 1 2 3. So let's just consider the center around 3 4, right? Let's consider the center around 3 4. So we start off at 3 4. Left sum is equals to 3, right sum is equals to 4, right? So we'll expand on the left one's place. So we'll expand on the left one place, we'll expand on the right one place. So what is the new left sum? Plus 2 is added, so 3 plus 2 will be 5. What is the new right sum? 4. 1 is added plus 1, so 4 plus 1 will be 5, right? So 5 5, they are same, the sum is same, so we'll mark the answer. What is the answer? Length of this substring, what is it? This pointer minus this pointer plus 1, right minus left plus 1, so it will become 4. The size is 4, right? So it will become 4, and like this we will continue. So if you look into the code, I have exactly done this. I have first fixed the centers, pointer 1, pointer 2, these are the centers initially starting at 0 1. Answer is 0 initially, so we'll move till the end. Like this is the last position where we'll move up to, right? This is the last position we'll move up to, and after this it will end basically. So while pointer 2 is less than n, LSUM is get digit value. Get digit value just returns the value of the digit. So for the current pointer 1, it will give its value to the left sum. The right sum will be the pointer 2, the value at pointer 2. Now if left sum is right sum, will the length of the substring is 2 initially, right? It is 2 initially, these two elements, it is 2 initially, so it will be max of answer comma 2. Now left is pointer minus 1. Now we'll expand along this center, so pointer minus 1, right is pointer 2 plus 1. While left is greater than equal to 0 and right is less than n, left sum plus equals to great digit value will add the left pointer value to the left sum, the right pointer value to the right sum, and if it is equals to same, we'll update our answer to the size of the subarray that we are considering. And we are going for left minus minus, we are decrementing left by 1 place, we are incrementing right by 1 place. So is it making sense now? Is it clear now? How we are getting this done? Any doubts on this? How is this how is this working? Any doubts on this? Clear. Okay. So is it clear with everyone? Is it? It's totally fine, John. It's totally fine. No worries. No worries. Let me know if it is clear with everyone. Cool. Cool. So thanks for joining in, and yes, enjoy your day off, like rest of the Sunday off. Cool. Okay, I'll see you in the next class. Like I think I'm running an Amazon series like on interviews. It's a 29-day challenge where I'll be solving around 2 problems every day and some problems for homework. And try joining those classes as well, because again, like you will get in the practice zone, where because when you are actually appearing for your interviews, you have 700 questions in front of you and you think, hey, how can I complete them, right? And even solving 100 question becomes difficult in that situation. So we have to develop a practice around that. So I'll be also solving with you so that you are in the practice zone, and do join that series. Like we have already started, we have already done one class. We'll be doing full-fledgedly from the next week, so do join there, right? So yep, thank you for joining.